Look up, see that bright star? It's a beacon in the night sky, a point of light that has fascinated humanity for centuries. That's not a star, not really, that's Venus, our sister planet. Often called the morning star or the evening star, Venus has been a symbol of beauty and mystery throughout human history. Earth's twin in size and gravity. Both planets are nearly the same size, and their masses are quite similar. But the similarities end there. But don't be fooled by appearances. Venus is a world of extremes, a planet where the surface temperature can melt lead. Venus harbors a secret, a hidden fury. Its surface is dotted with volcanoes and its atmosphere is a swirling cauldron of toxic gases and violent storms. Her beauty is a mask, concealing a world of fire and acid. The clouds that shroud Venus are made of sulfuric acid, and the atmospheric pressure is crushing. For centuries, we dreamed of life on Venus. Early astronomers and science fiction writers imagined lush jungles and alien civilizations, jungle planets teeming with strange creatures. These visions captured our imaginations and fueled our desire to explore. Science fiction fueled our imaginations. Then, reality hit. The first space probes sent to Venus revealed a harsh and unforgiving environment. Space probes pierced the veil, revealing the truth. Venus was no paradise, it was a furnace. The data sent back was shocking, painting a picture of a hellish world. Yet even in the face of such hostility, the human spirit refuses to be deterred. We are driven by curiosity and the desire to conquer the unknown. Where others see obstacles, we see opportunity. The challenges posed by Venus only serve to inspire us to find innovative solutions. We see the challenge and we rise to meet it. Engineers and scientists are already working on designs for habitats that could float above the planet's deadly surface. For in the heart of this inferno, a spark of hope remains, the possibility of life in the Venusian sky. High above the surface, where the temperatures and pressures are more Earth-like, we may one day find a way to thrive. Why Venus? Why should we set our sights on this seemingly inhospitable world? Why venture to this hellhole, a planet with surface temperatures hot enough to melt lead and an atmosphere thick with toxic gases? When Mars, with its dusty plains and whispers of ancient water, seems so much more inviting. Mars, with its potential for terraforming and the possibility of past life, has long captured our imagination. The answer lies in the very challenges Venus presents. These challenges are not just obstacles, they are opportunities for innovation and discovery. For within those challenges lie unique opportunities. Gravity. That invisible force that anchors us to our world and shapes our very existence. On Venus, gravity is nearly the same as it is on Earth. This similarity in gravity means that our bodies would not suffer the debilitating effects of long-term exposure to low-gravity environments. On Venus, gravity is nearly the same as it is on Earth. This means no bone loss, no muscle atrophy, no need for cumbersome artificial gravity systems. This means no bone loss, no muscle atrophy, no need for cumbersome artificial gravity systems. Our bodies would feel right at home. Then there's proximity. Our bodies would feel right at home. Then there's proximity. Venus is our next-door neighbor, a cosmic stone's throw away. Venus is our next-door neighbor, a cosmic stone's throw away. This proximity means shorter missions, faster communication, and easier access for supplies and support. Mars, on the other hand, is a distant cousin requiring months of travel just to reach. The long journey to Mars poses significant challenges in terms of life support, psychological well-being, and mission logistics. This proximity means shorter missions, faster communication, and easier access for supplies and support. The shorter travel time to Venus reduces the risks associated with long-duration space travel. Yes, Venus is a harsh mistress. Its surface is a searing inferno, and its atmosphere is a crushing blanket of carbon dioxide and sulfuric acid clouds. But she is also a land of potential, a place where human ingenuity can be put to the ultimate test. And the rewards? The rewards could be beyond our wildest dreams. Imagine harnessing the power of Venus's atmosphere for energy, or developing new technologies to survive and thrive in extreme conditions. The rewards could be beyond our wildest dreams. Venus beckons us not just with its challenges, but with the promise of pushing the boundaries of what is possible, of expanding our horizons and reaching new heights of human achievement. Imagine a world where the sun is a distant memory, choked out by perpetual cloud cover, where the air is heavy, thick with carbon dioxide, a suffocating blanket trapping the heat. This is Venus's surface. The temperature here is hot enough to melt lead, the pressure, crushing. It would feel like being thousands of feet beneath the ocean's surface. Sulfuric acid rain falls from the sky, though it never reaches the ground. It evaporates long before, adding to the oppressive heat. No human could survive in this environment, not without extensive protection. Our technology, advanced as it may be, is no match for the raw, untamed power of Venus's surface. But what if we didn't have to land? What if, instead of battling the Inferno below, we looked to the skies above? High above the scorching surface of Venus, something remarkable happens. The oppressive atmosphere, so hostile at ground level, begins to transform. The temperature cools, the pressure eases, and the clouds themselves become a source of unexpected beauty. At an altitude of around 30 miles, a magical zone exists. The temperature here is a balmy 70 degrees Fahrenheit. The pressure similar to Earth's at sea level. This is Venus's temperate zone, a haven from the hell below. And it's here, in this unexpected paradise, that the seeds of human habitation could take root. Section 5. Islands in the sky. Imagine this, floating cities, suspended like shimmering jewels in the Venusian sky. Giant habitats filled with light and life, powered by the endless energy of the sun. This is the dream of Venus colonization. These wouldn't be cold, sterile space stations. They would be vibrant, self-sustaining ecosystems. Greenhouses would provide fresh food and oxygen. Advanced recycling systems would ensure that every drop of water is reused. And the Venusian atmosphere itself, thick with carbon dioxide, would provide all the raw materials needed for construction and resource production. These floating cities would be testaments to human ingenuity, beacons of hope shining brightly against the backdrop of Venus's unforgiving surface. Section 6. Breathing life into the clouds. Building a floating city is no easy feat. It requires meticulous planning, advanced technology, and a deep understanding of the environment we are venturing into. The idea of creating a habitat in the clouds of Venus is both thrilling and daunting. The challenges are immense but not insurmountable. Engineers and scientists must work together to solve problems that have never been tackled before. From the structural integrity of the buildings to the sustainability of life support systems, every detail must be carefully considered. First, we need to address the issue of buoyancy. Ensuring that these massive structures can float in the dense atmosphere of Venus is crucial. This involves complex calculations and innovative designs to create a stable and secure habitat. How do we keep these massive structures afloat in the Venusian atmosphere? The answer lies in understanding the unique properties of Venus's atmosphere and leveraging them to our advantage. The answer lies in the air itself. By studying the composition and behavior of the gases in Venus's atmosphere, we can design habitats that naturally float. Venus's atmosphere is primarily composed of carbon dioxide, a gas that's actually lighter than the nitrogen-oxygen mix we breathe here on Earth. This unique characteristic can be harnessed to create buoyant structures. A gas that's actually lighter than the nitrogen-oxygen mix we breathe here on Earth. This means that a habitat filled with breathable air would naturally want to float, much like a helium balloon rises in our own atmosphere. This means that a habitat filled with breathable air would naturally want to float, much like a helium balloon rises in our own atmosphere. This principle is fundamental to the design of our floating cities. Much like a helium balloon rises in our own atmosphere. But buoyancy is just one part of the equation. We also need to consider the harsh environmental conditions on Venus. Then there's the question of protection. Venus's atmosphere is harsh and corrosive. The clouds are filled with sulfuric acid, which poses a significant threat to any structure we build. Venus's atmosphere is harsh and corrosive. We'll need to develop advanced materials that can withstand the constant bombardment of sulfuric acid and other corrosive elements. This requires cutting-edge research and innovation in material science. We'll need to develop advanced materials that can withstand the constant bombardment of sulfuric acid and other corrosive elements. These materials must be both strong and lightweight, capable of enduring the extreme conditions while maintaining the buoyancy of the structures. But again, these are challenges that can be overcome with ingenuity and innovation. The dream of a floating city in the clouds of Venus is within our reach, thanks to the relentless pursuit of knowledge and the unyielding spirit of human exploration. Section 7. Venus Rising. The journey to Venus will be a step-by-step process, a testament to human perseverance and our innate desire to explore. It will begin with robotic probes, sent to scout out the best locations for our floating cities and test the viability of our technology. Next, we'll send small-scale, unmanned habitats. These will serve as test beds, allowing us to refine our designs and ensure that we can create a truly self-sustaining environment. And then, finally, the moment we've all been waiting for, the first manned mission to Venus. It will be a historic event, a giant leap for humankind, the day we establish a permanent human presence in the clouds of Venus. Section 8. A new home among the stars. Imagine waking up every morning to a view unlike anything you've ever seen before. The sun, a pale disk through the clouds, casting an ethereal glow on the swirling Venusian atmosphere. Below, the hidden surface, a reminder of the challenges we've overcome. Life on Venus will be different, yes, but it will also be extraordinary. We will learn to adapt, to thrive in this new environment. We will push the boundaries of science and technology, developing new ways to live sustainably and harmoniously with our surroundings. And in the process, we will discover new truths about ourselves, about our place in the universe, and about the limitless possibilities that lie ahead. Section 9, to Venus and beyond. The colonization of Venus is not just a dream, it's a necessity. As we continue to push the boundaries of human exploration, we need to look beyond Earth, to find new homes among the stars. And Venus, for all its challenges, offers us a unique opportunity. It's a chance to prove that we can overcome even the harshest environments, that we can turn adversity into opportunity, and that the human spirit, much like life itself, will always find a way. So let us set our sights on Venus. Let us dare to dream of floating cities and a new era of human exploration, for the future awaits, and it belongs to those brave enough to reach for it.